Hello everyone, this is my part 3 to my calculus series, and this is differentiation by exponent rule. So hope you're ready for that, and I hope you watch the first two videos because they'll help you understand this. So last lesson we went over how if you have the function of any graph, you can find the derivative of it, or the gradient function of it, which is this. And you can use that by using the first principles of calculus. Let me just finish writing this. Lim n approaching 0. Okay, so we spoke about that. However, as we saw with this cubed number, it was a huge amount of work and very complicated and very easy to get wrong. So today I'm going to show you the process that's way easier and simplifies a lot. So this is called the exponent rule. Exponent rule for differentiation. And so actually something that I didn't go over last lesson is that what's the notation for this? Well, the notation is actually a couple types. First of all, it could be f dash x. So, for example, my first notation could be f of x equals x cubed plus 4x squared minus 9. So f dash x equals 3x squared plus 8x, which is our gradient function or derivative. Another way we can notate this is dy over dx of x cubed plus 4x squared minus 9 equals 3x squared plus 8x, like that. So that's another way we can notate this. So now on to today's lesson, the exponent rule. So the exponent rule is a formula that we can use to simplify the process, and the formula looks like this. So if f of x equals ax b axn plus bxn plus cx and this can go on for as many times as you want. You can have as many this can be as polynomial as you want. It can have as many different parts. So so the way you'd find out the derivative of that, f dash x, would be an multiplied by x to the power of n minus 1 plus bn times x to the power of n minus 1 plus cn x to n to the power of n minus 1, and forever and ever, for as many terms as you have. So this might look a bit complicated, but what that basically means is that if I have f of x equals 2x cubed plus x squared plus 8x, and let's just say it's minus 9. Remember, this minus 9 is the same as saying 9 to the power of 0. Okay? So it's always a 9 to the power of 0 because this is 1. Remember that, okay? So let's say this is our function. When we're going to differentiate this, we're going to get this 3, as it says there, and we're going to multiply it to the front. So it's going to be 6x, and then this 3 is going to decrease by 1. It's going to be 6x squared. And again, we're going to multiply the 2 here, 2x, and it's going to go down to 1 plus 8x 0 minus 0x to the power of minus 1. Now, you might be like, there's a couple things not right here. And yes, that's true. Because if we write it like this, that's going to equal 6x squared plus 2x plus 8. Because x to the power of 0 is 1. So that's just 1 times 8, so it's 8. And if we multiply anything by 0, it's still 0. So if there's a term without an x in front of it, like here, which is already x to 0, we just ignore that term. We only look at the terms that have a coefficient of x 1 or higher, x to the power of 1 or higher. So no coefficients of nothing. So it's going to be like that. Similarly, what we did last time, our equation was x cubed plus 4x squared minus 9, and that was our graph. So if you want to differentiate that, that's going to equal 3x squared plus 8x, and then we ignore that. And we get the exact same answer as what we got last time, but so much, the working out is so much smaller. Okay, let's do it one more time. So f of x equals x to the power of 2x to the power of 8 plus 3x to the power of 4 minus 18x. So if we want to differentiate that, x plus, let's say that's x squared plus 19x. Now if we differentiate that, that's going to give us 16x to the power of 7 plus 12x cubed minus 36x plus 19. And that's our gradient function, which means that for any point on this graph, if I plug the x value into here, it will give me the gradient of the area. Now, one really cheeky thing, and one thing that this actually really helps us with in maths, other than just working out the gradient. So let's just say that I have this graph. It's a cubic graph, f cubed, but this could be any graph. F of x equals x cubed plus 3x squared plus 3x plus 1. Very, very basic cubic graph. And let's say I want to work out the turning point. Well, what is the turning point of any graph? On any graph, the turning point is going to be wherever on the graph. So this is one turning point, and this is another turning point. The turning point is going to be wherever the gradient equals 0. Because you can see here, the gradient is not increasing or decreasing. The gradient equals 0, and the gradient equals 0. So what can we do? Well, let's differentiate this graph. Bring the 3 down. 3x squared plus 6x plus 3. And we want that to equal 0. We want that to give us a gradient of 0. So 3x squared plus 6x plus 3 equals 0. Now we can solve. And we can just solve that as a quadratic. So to make our lives easy, we can divide all by 3 equals 0. And that's just going to give us x plus 1, x plus 1. So x equals minus 1. Now this graph's a bit special because it only has one turning point, even though it's a cubic graph. But I can demonstrate you with another graph. So let's say this graph is f of x equals 2x cubed minus 18x squared plus 9. Well, if I were to differentiate that, that would give me 6x squared minus 36x plus 9. Sorry, we ignore the 9. So plus minus 36x. So if I made that equal to 0, minus 36x equals 0, and divide it all by 6, sorry, x squared minus 6x equals 0. factored out 6 equals 0. That means that x equals 0 and x equals 6. So the points on the graph where x equals 0 and x equals 6, that's where the turning points are. So if I plug this back into the original graph, that'll give me the y-coordinate as well. So this is quite a cheeky way to work out the turning points of more complex graphs rather than solving the square. Okay, hope you found this lesson useful, and see you next lesson.